Oopsies. So, we begin energy. And the first thing we need to discuss relating to energy is the idea of systems. That raises the question, what is a system? If I'm being absolutely honest, the answer in a way is quite vague and in other ways is quite specific. So to give a precise definition for it, a system is the part of the universe that we choose to focus our attention on. Grammatically, I could have put that better, but that's pretty vague, but it is a precise definition. We divide the universe up into the rest of the universe and our system. So the system is just a small piece of the whole universe. A system can be a single object, a group of objects, or a region of space. Systems don't have a fixed boundary. They must continue to contain the same things that they have always contained. You can't start considering two objects and then halfway through change to just one. You have to keep considering both objects. But those objects can move far apart, so the boundary of the system can completely change its shape. It's very flexible. So the boundary can grow or shrink. But the objects contained cannot change once you have begun. Okay, so sort of a quick drawing example of this would be, imagine you have the Earth as a great big object and you have some smaller mass interacting with it. You can set up your system in any of two ways. You can choose to make your system just the mass, and you can think about the gravitational force acting on it that will cause it to fall towards the Earth. So one system would be mass alone. But you could just as easily take the same idea where you have the Earth, and you have your little external mass, and you can set the system up to be something that kind of includes both the Earth and the mass, but not really anything else. So the system is now Earth plus mass. And what you notice is, as the object falls towards the Earth, as it gets closer and closer, the boundary of the system will change. It will only ever include those objects, so it will have to shrink as time goes on. If you imagine launching instead a rocket to Jupiter or Alpha Centauri, and you wanted to consider the Earth and the mass as a single system, the system's going to grow really large. It's going to get really awkward looking. But it is something you can do, and something we will be doing in future problems. So when you hear me start talking about what is the system, that's asking you to think about which objects or things or forces are included as part of our boundary, as part of our system separate from the rest of the universe. And we have a lot of flexibility in that. Sometimes we can take, like this case, just the single mass is the object, it's the system, and the Earth is outside the system, it's part of the universe. Then other times we may choose to make both the Earth and the mass falling towards it part of the system. There's a lot of flexibility. So you will hear this terminology a lot. I'll ask this question a lot. That's it for an introduction to just systems. While we're here at the beginning of energy, I'm going to introduce one other concept, and that is the units of energy. So energy is measured in joules. typically. Sometimes kilowatt hours. We'll talk about that towards the end of the chapter because a kilowatt hour is sort of a funny unit. So you hear that from your power company every month when you pay your bill, but it is a unit of energy and not in fact a unit of power that you might suppose. All right, let's talk about the joule for a moment. 1 joule, symbol is just capital J, is equal to 1 Newton times meter. Or you can break it down even further, and 1 joule is 1 kilogram. Hold on a moment. Back. Put the 1. Then we have kilogram meter squared per second squared. So 1 joule is 1 kilogram meter squared per second squared, or it is 1 Newton times meter. I like knowing these base units because I use dimensional analysis to check myself all the time, so knowing that a joule is a kilogram meter squared per second squared is a good thing to know. All right, last idea I want to get across. If you have heavy ceramic plates at home, and you use a dishwasher, a machine that can wash your dishes that's usually down near the floor, and you store them in a cabinet at head height, roughly, then it takes about 1 joule of work to put the plate away. So you've got your dishwasher down around your knees, maybe your ankles. You take your heavy plate out of there, you lift it up, you put it up somewhere around chest to head height, and that is roughly 1 joule's worth of work. It's a fair amount of work. As another example, I weigh around 900 newtons. If you wanted to lift me from one floor of a building to the next floor up, that's going to be on the order of 2,500 joules or so. It's a little over 2 meters, maybe a little less than 3 meters to go through that height. So it's a lot of energy compared to a single plate, obviously, but you're lifting me higher and there's a lot more of me than there is of the plate. Okay, so that gets a lot of the introductory ideas out of the way. With the next section, we're going to start talking about the concept of work. So I'll see you back for the next one talking about work.